We are live. We are
Did
live.
it.
Hello, world.
Hello, world.
It's the classic team with Pamela.
I
Welcome
was
back.
doing Weekly Space Hangout in the early days.
Yeah.
The very
I
early days.
remember.
I mean, if we could dig up Paul Sutter, then maybe that would.
Yeah,
that would
I
make
almost
the full
texted
crap.
him. Like, he's like doing a billion things these days.
Yeah, he's probably
We could throw up a photo of him.
doing some kind of
Anyone have a...
interpretive.
Well,
I was
just
on
have
it.
him show up.
As
Working
I,
on it.
No, I wouldn't put Paul on the screen
Yeah.
because then he'd feel like he'd have to take responsibility for it.
as I
Okay.
do, I was scrolling through Universe Today about 45 minutes ago, looking for my second story, and saw like he had a story that you were like today, or that you published today, and it's like,
Yeah.
oh my gosh, I was scrolling through. I was like, hey, I know that person. I know that person. I know that person.
Yeah.
It's just like the whole team.
Yeah, it's great. So Paul is still doing a lot of writing with Universe Today, and it's great because he takes on the stuff that other people won't touch with a 10-foot pole, right?
Like
So if it's like
quantum
some
mechanics.
kind of challenge to dark matter or particle physics or extreme physics,
Or
Paul's
by
all
Ave
over it.
Loeb.
yeah. Well, I don't think he wants any part of that, but the stuff that's very technical, right? That requires a certain level of astrophysical knowledge to at least even know that you're describing it correctly. Paul grabs those kinds of stories, and so it's a level of coverage. Same with Brian Coberline. Like both Brian Coberline and Paul, it's such a pleasure to have both of them reporting on stuff for Universe Today because they get that part right, and it's so tricky. Like anybody can describe a rocket launch, but to describe why new evidence points to dark matter, the story picked up last time, Morgan, is that's
Yeah, well,
That's no
everybody
trickier.
saw how I fumbled that. Like 7 years ago or something, I got a call from a BBC producer or something, and they were working on one of these, universe shows or whatever, and they were asking me questions, and they were just like crazy questions. And I finally said, how did you find me? And it's like, oh, Paul sent us to you. Like, oh, yeah, this is the kind of crazy questions that are right up Paul's alley, and he makes them sound sensible. And I was just like, no, I can't help you with what happens if Uranus becomes a black hole. It's like bad things, and that won't happen. It was just the weirdest thing. He's like, oh yeah, Paul thought you would like this. And I was like, oh, I'm not as
Thanks,
adventurous as Paul.
you get to be on TV.
I know. I gave too much straight answers, and they did not call me back. That was the beginning and the end of my TV career.
Yeah.
Which
Well,
is
you're a
probably-
planetary scientist, so you know the Uranus part, half of that.
Yeah, what's the
that
Schwarzschild
thought
radius
experiment.
of Uranus?
Yeah, it was very small, very
Yeah.
very small. But I was not good at playing along with some of the ridiculous scenarios.
Yeah. All right, should we get started?
Let's do it.
All right.
All right. Hold on, I have to press record.
Also, Pamela,
press
I don't know
record.
if you're showing graphics or anything. I don't see anything.
Let me switch that over so you guys are seeing what's going
I
on.
didn't put any things in the spreadsheet.
I already got you.
Thank you. Oh,
I
perfect.
remembered.
Show off.
Duh. Have you met me?
This is the first time someone dropped out this week because of jury duty.
Yeah. I saw
Yeah.
that.
Wow.
That's new. Are you ready, Pamela?
Yeah.
Oh, okay, you didn't tell me. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, January 11th, 2023. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Andromeda and the Milky Way, doomed black holes, where's China's Mars rover, stranded ISS cosmonauts, 2 Earths for Tess, and good night for Insight. Joining me today, we've got Dr. Kimberly Cartier. Hey, Kimberly.
Hey, Fraser. Happy podcast day.
We've got Dr. Pamela Gay, our engineer, but also one of our co-hosts today, filling in for
Hello.
jury duty. And we've got Dr. Morgan Rimberg. Hey, Morgan.
Everybody, I'm so glad to be here.
All right. So before we get into this week's news, it's time to make a big, sad announcement. And that is that this is the final episode of the Weekly Space Hangout. And I know this is going to come as a surprise to everyone watching us live right now, everyone who's going to be watching the show in the next coming weeks, and everybody who's listening to this as a podcast. It's not a joke. This is the final episode. There will be no more episodes after this. I'm sure you're wondering why. Why is this the last episode of the Weekly Space Hangout? Isn't this a thing? Hasn't it been going for 11 years? Yes. Yes, it is. Yes, it has. And it's time to wrap it up. And there's a bunch of reasons why. So the first one is that it was created in another era. It's right there in the name, the Weekly Space Hangout. That was a technology created by Google Hangouts, and we jumped on that and worked with it. And then Google sunsetted the technology, and we kept going with the
It's
name.
all Google's fault.
Google's fault.
In the end.
Yeah. And then the second thing is that just by its very nature, with a rotating cast of journalists who have careers, who have families, who have lives, it's a cat herding problem of momentous proportions. And it's the same problem that we had with Virtual Star Party, which is that it just gets so hard to organize this thing week after week after week. And, everyone is familiar, of course, with our producer, Nancy Graziano, and she's been doing this for like a decade and has just gotten, to the point where she can't put any energy into keeping the show going week after week after week. And I don't have the time to organize it. Pamela doesn't have the time to organize it. At the same time, it's not like the show is gigantic. It's not like the show can bring in enough funding to pay people to organize it behind the scenes and to pay the various journalists. It was just running on goodwill and volunteer effort by everybody. Like, I don't get paid for this. Pamela doesn't get paid for this. Nobody gets paid for this. It's a collaboration. It's a volunteer collaboration. And at a certain point, it had to run to an end. So that is what's happening today. Did I cover that? Was there anything else to sort of explain?
No? I think that really describes it. And we've reinvented the show several times over that 11 years. We kind of saw this coming years ago and tried the format where we had Kim and me and Paul and Fraser week after week after week to try to reduce some of those complexities. And it was good, and we had a tremendous amount of fun. But it just didn't grow it. It was hard for us to sustain it then. Then we tried this new format with the up and coming grad students, and that was, I think, really powerful. But students are busy people, and we became busier people, and it was just like we tried for a long time to make this work in a way that was easy and seamless for everybody. And I think we gave it all we had and had a lot of fun along the way.
Yeah, I mean, and at this point, a lot of the stuff that the Weekly Space Hangout does is covered by the other stuff in our network. So I'm doing the news Space Bites every week. I'm doing all of these really in-depth interviews on my channel. Pamela with CosmoQuest is doing news every week, as well as other interviews and stuff. So we have all that content in other formats. I think the one thing that I really love, and this was, for both Kimberly and Morgan, it was a chance to take somebody who didn't have a lot of experience as a science communicator and give them that experience week after week after week, to forge them in the flames to become it's something you put on your resume, and then that will do you justice when you have those TV appearances or when you are attempting to write for the public or any of that. And that was the thing that we were trying to accomplish this time around with all of the students that we were bringing on board, was just like take people who want to be science communicators and give them a place that is caring and protective, but also pushes them out of their comfort zone and gives them a chance to talk about science in front of a public audience and have questions that they don't know where it's going to come their way, and it builds experience. And that was the one thing that I haven't figured out how to reincorporate it into what I do, but it is a gigantic priority for me to keep that piece of the puzzle going, to give young people a platform.
Mm-hmm.
I mean, I'm so proud of the work that we did in that realm, and so grateful. It's literally, I've done this my entire professional life. I was a first or second year grad student the first time I was on, and I was like sweating bullets. It was insane how nervous I was the first time, and I had written everything out, and I had paragraphs, and I just, I have a tally, and I think this is like my 190th time doing this, which is, nothing compared to Pamela and Fraser and Astronomy Cast and all that, but it's really been a defining thing for me, and it's hard, it was hard to go from the weekly thing to the new version. It's going to be hard to go from this to nothing, so I'm going to be knocking on the door of Astronomy Cast and whatnot in the future saying, let me talk about space.
Yeah. I mean, it's just us friends here, but New York Times does a show every day called The Daily, and they bring in a different journalist every day to talk about a story that they're reporting on. And I really like their format, and I really want to steal it. So I think that's probably the model that I'm going to try to do. And then once a month or so, I may be talking to Kimberly about something she's writing for EOS, and that'll run on my podcast feed. So that's kind of my thinking. Yeah. Randomly 3 says, is Astronomy Cast okay? Yeah, Astronomy Cast is totally fine. Yeah. It's just like, I should know better. Well, I mean, how could I have known better? When I started this whole thing a decade ago, which is when you try to bring together a large group of people, it is really hard, and it just wears people down.
Yeah.
And that's just the bottom line.
And I have to say kudos to Nancy, because I watched her and other folks both work really hard to bring on guests, find guests.
Yeah.
And as the pandemic has kept going, the number of news stories coming out has dropped. The number of research papers coming out has dropped. And our ability to find people who have the time to come on as guests, she was like the last human standing when it came to being able to successfully find guests. And it was amazing that she was doing what she was doing.
Yeah. I mean, like
we had the easy job. We got to show up and chat with good friends for an hour every week or every few weeks, and read a couple stories an hour before, and that was the easy part. And if it was just that, it was in the early days, it might have been a different thing. But so many people, so much effort, none more than Nancy to making this happen, and we just can't persist on that goodwill forever. That wouldn't be fair to anybody.
Yeah, I mean, it was definitely wearing her out, and like, I think for me, like, I think we knew. I mean, you guys had wrapped up, because you didn't have the time commitment or whatever. But for me, I sort of had two motivations to keep rolling week after week. One was to try and give those new science communicators a platform, a way to get some experience, and the other one was to make Nancy a TV show, right?
Yeah.
I mean, that was the goal. The goal was
her baby.
It was her baby. Yeah. And the way we could pay her back to do the organizing behind the scenes was to make a show that she would want to watch, that would bring the heroes of the space age in front of her and have all of this stuff come together. So if she's ready to wrap up her work on this, then that's the heart of the show. And I think it's the right turning point at this point, and a good time to shut things down. And so I know for every person who's ever interacted with Nancy Graziano behind the scenes, she's a superhero, and this show would not exist. Like, I guarantee it just wouldn't be without Nancy's help all of these years. So and so many different things. She was my right-hand human for so many years, and
like any good right-hand human, she didn't just get shit done. She also kept everyone stable when the desire to just like vibrate into another alternate dimension was there, and that rock is
Yeah. And
So
I have to say, I haven't said my piece yet, but I just want to echo everything that Morgan said earlier in that, like, I've been a part of Weekly Space Hangout probably for a couple years fewer than Morgan and Fraser and Pamela, but it's certainly been almost 8 years now, which is the entirety of my professional career, most of my grad student career. Please don't go back to watch that first episode that I was in, because it was pretty awful and that was terrible. But if you do and you compare it to anything that I've like over the years, like this show has helped me grow so much as a communicator. It certainly like solidified my desire to want to talk about science to people who aren't scientists. And like Nancy and Fraser and Pamela and Morgan, like all you people, everyone who's been involved in the show and the crew and everybody, like you've helped me become who I am now. And that's like, there are no words to express how grateful I am for that. And I'm getting all emotional, man. Like this is the right move for us at this time. Like this is the right thing for us to do, but at the same time I'm very sad to see it go because it's played such a huge role in my life. So that's my thank you to everybody.
So I've got something to read from...
I'm not crying.
You're crying.
I'm crying a little bit.
So I've got something to read out from the Weekly Space Hangout crew, and that's, of course, the community behind the scenes. When the first Weekly Space Hangout went live 11 years ago, there was no community and no chat to accompany the show yet. But soon, the first conversations emerged in the Google Plus event pages, and one day when the show was canceled, we made our show right there in the primordial chat, seeking out the news ourselves. Moments like this led to the evolution of the Weekly Space Hangout crew that was always appreciated by Fraser Cain and an amazing group of journalists. They loved us being there and harnessed the power of the community to literally drive the show by making us all producers. First born as a Google Plus community, we even survived the demise of a whole social network, becoming platform independent with the help of our own website, Slack, and Discord over the years. Sadly, times have changed, and while the Weekly Space Hangout is not going to be around anymore, the WSH crew community will continue to live on. Thank you, Fraser, and all the wonderful journalists and guests for bringing us together and creating such a wonderful community. And that was Guido Bibra wrote that.
Well, I think the crew is one of the defining things that made the show work. And I sort of continue to believe that it's kind of sort of semi-miraculous. It's like, who goes to YouTube videos and reads the comments and thinks, that's a good place to be? Like that doesn't exist on the internet. And yet,
certainly,
the crew and Nancy fostered such a welcoming, encouraging, inquisitive place that we felt comfortable to bring all of these people who are taking their first baby steps on the internet here to do that. And thank you for all of that. You know, even if we'd all wanted to do this, we never would have continued it if there hadn't been passionate people watching. And so thank you for giving us the excuse for so long to do something so fun. And I can't wait to continue to interact in other media as we go forward.
Yeah, that was a really fun experiment in collaboration with an online community in just giving them 100% of control. Because again, like it's all just a collection of volunteers. And so I just said, I can't think about the actual construction of the show, like the guests, all that. Just so you as the fans just pick your guests and we'll interview them. And that worked amazingly well. And as you said, Nancy became this laser cutter, being able to go after the various guests that she wanted to see on the show. And that was amazing.
It's time to go get your second career booking for Stephen Colbert or something.
Like
it's probably easier.
Possibly. Yeah, 100%. Yeah. I know how hard it is to organize interviews, and it's
you have no idea how many spreadsheets there are on the back end.
Oh my goodness. So many spreadsheets.
Yeah, 100%. All right. So that's the big
face.
Let's talk space. Yeah. So that's the big piece of news. So let's move on to the space part.
Less
So
important news.
Pamela, let's talk about Andromeda and the Milky Way. Closer together than we thought.
Yeah, I absolutely love this particular story. Researchers using my absolute favorite kind of stars, aurora stars, were basically trying to map out the outermost halo of the Milky Way galaxy and figure out just how far does it go. And the trick is finding stars that are definitely Milky Way, and with enough data you can do that. And they found that those stars are halfway between here and the Andromeda galaxy. Now,
So wait a second. So does that mean that like the ones in the Andromeda galaxy are halfway between there and here?
so here's the thing to think on. The Andromeda galaxy is bigger than our galaxy. And if those stars are halfway between the center point and the center point, that means that our two galaxies are basically currently doing the "I'm not touching you" thing,
Right.
where the stars are starting to have orbits where it's not too long before they'll start to be influenced by the other center of mass. And this is not something that was on my radar to learn about. Now, unfortunately, it is hard to tell if they were basing the halfway there on the outer edge of the Andromeda or the center of the Andromeda, because they simply said the distance to, which is a very vague statement. So if it's to the edge of Andromeda, it still doesn't make all that big of a difference because Andromeda is 1.54 million light years away, and it's about 200,000 to 300,000 light years across. So that difference between the center and the edge is kind of minuscule. And yeah, we're pretty close to stealing stars from one another, playing a dance of "I'm not touching you."
So I guess that's why it's so difficult to say when are we going to merge with Andromeda.
Yes.
It has already begun.
And so where it starts to become interesting is all of our models are talking about when is the morphology going to start getting interacted with, when are we going to start to see noticeable global sized effects. And here I show artwork from a simulation of the two systems coming together and what it will look like from our world nominally. But we start stealing stars from one another effects might start to become noticeable on generational levels in the nearer future. And that's cool.
But Pamela, the one headline that I saw about this said that these stars that were halfway between us and them were still in the Milky Way. Like,
Yes.
What's the premise for which they are sort of arguing that?
As near as
Like,
I
you think
can...
if they, to your point, Andromeda's heavier, so you think halfway between would be more in its gravity well than ours.
Wouldn't it be the redshift of the star? Like
No,
stars
not...
in Andromeda are blue shifted towards us, while stars within the Milky Way
Well,
aren't.
so if they're moving tangential to our field of view, that's the galaxies, sure, blue shift versus red shift, but individual stars you can't do that with so much. What you start looking at is, do the compositions of these stars work consistently with the composition of similar halo stars in the Milky Way? And you follow their motions to see if they seem to be orbiting. And they seem to be ours. But yeah, it's a real question. At what point do we find a star that appears to be Andromeda's and is really about the same distance? And now I really want to go figure out, where do you start getting that point where stars are gravitationally balanced between the two systems? And I don't know that answer, and now I really want to know that answer.
There's some kind of Lagrange point between the galaxies that is not something we've really thought about.
Mm-hmm.
Yeah.
Yeah,
Well,
interesting.
not sure it's a Lagrange point, but there's a quasi-stable point between the two of them.
Right, a point where like they're the top of a gravitational hill and they want
Yeah.
to slide down
Right,
into
yeah.
Andromeda or stay with the Milky Way.
Yeah.
All right, Morgan, the Chinese can't wake up their rover.
Yeah, it's been a bad winter at Utopia Planitia on Mars. So back in 2021, China landed a rover, which you can see in this awesome picture. This is not a rendering, we should say. This is an actual picture taken with a dropped-off camera that they dropped off and then backed up to get this great selfie. And China's only the second country to successfully land and operate a spacecraft on the surface of Mars. It was supposed to last for 3 months. In classic Mars fashion, it's lasted for more than a year now. But over the summer, it had to be shut down because southern Mars was entering its winter time. And winter on Mars is like cold, 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 cold. And this has been a particularly bad winter. Temperatures have dropped well in excess of 100 degrees Celsius below zero. And spacecraft just aren't really designed to survive that super well. So they shut the instruments down to try to preserve things. And they programmed the spacecraft to wake up on its own. And it had to have two conditions for that to happen. Its solar panels had to be generating at least 140 watts of power. And its primary instruments had to be warmer than negative 15C. And both of those conditions seem like they should be happening now. And they had projected December 26th as the date at which those thresholds would be met long enough that the spacecraft would activate its wake-up procedure, basically. Well, that hasn't happened, and we're now 2+ weeks after that. There's not a whole lot of, like, they can do to wake it up. They've just got to kind of wait and hope. They've got an orbiter that's alongside this mission that carried the rover out there, and they're going to try to reposition that orbiter to take some photographs of the landing site to see if they can spot anything. And that might provide some more information. But for now, let's just kind of wait and hope season.
T-Car saying in the chat, I guess Perseverance didn't take jumper cables with it, did it? So that would be awesome to have one of the rovers come over and give it a jump.
This is a crowning achievement for the Chinese Space Agency. To operate a spacecraft on Mars, for it to last at least 4 times as long as the nominal mission was. It's not a Curiosity, it's not a Perseverance, but this is a powerful first step, and they've made some real scientific discoveries. They brought a ground-penetrating radar, which nobody's ever brought to Mars, like that on a rover, and they used it to discover layers of sediment beneath the surface that indicate possible flooding in this valley where it landed. And I think we've said, for every year this show has been on air, we've said people exploring space is more better. And this is a really powerful indication of that. It's, NASA is not going to be the only people, shouldn't be the only people on Mars. And China's learning the hard way that, just doing it comes with its own risks, but their payoff has been amazing.
I do love that they are specializing in this ground penetrating radar. They had a similar instrument on one of the Chang'e missions on the moon, and they were able to peer down through the regolith and see how the sizes of the objects got bigger and bigger until it was boulders down below, and they were able to map out how deep the crumbled up regolith goes on the moon. And then to take a similar machine to Mars is fantastic. And it's a great specialization to have, a series of engineers who've worked on many of these instruments just to take bigger and bigger ones. To be able to peer underground on another planet is astonishing.
It's just amazing.
Yeah. Speaking of Mars vehicles that are no longer calling home, Kimberly, let's talk about InSight.
Yeah, so December was not a terribly good month for missions on Mars. This one we knew was coming, though. NASA's InSight mission, which landed on Mars a couple years ago, 4 years ago, has slowly been losing power all throughout last summer. They anticipated that it would last until winter, and it did indeed. It called home for the last time on December 15th. And after 2 failed communications with the mission, NASA declared InSight over on the 21st of December, and we were all very, very sad. It was such a wonderful mission. Like, I cannot gush about it enough. The things that the discoveries that it made have sort of revolutionized our understanding of Mars and its current seismic activity and its tectonic history and its magnetic history. The most famous things of all are, of course, the Mars quakes, the first detections of quakes on Mars that are happening right now. In total, it found over 1,300 Mars quakes. I think it's 1,319, some of which were quite large, seismically speaking, and a lot of which they were able to pinpoint to one specific fault region on Mars, not too far away from where the lander is. Of course, it also did so many other amazing things. It was Mars's first weather station, so you could, get live, up-to-date weather readings on Mars, which was kind of fun. I used to check in on that to just see
how's the weather on Mars.
How's the weather on Mars today? Yeah. Cold, very cold. There was because it was able to map so many Mars quakes, InSight was actually able to get the first picture of the entire internal structure of Mars, from the core to the mantle to the crust, which we'd never gotten before. Mm-hmm. And we learned so much about what the interior of Mars is like, including what the composition of the core might be like, how much iron or nickel or how much volatiles snuck into the core, how deep the mantle is, how many layers to the crust there might be. All of this came from these amazing, very sensitive seismic measurements that it was able to take. And of course, we all know about the little snafu with the heat probe, but it was still able to, burrow itself a little bit down into the surface of Mars and take a couple measurements there, which, just the wealth of data that InSight collected, I'm sure we're going to be talking about it for many, many years. And, 4-year mission, it wasn't supposed to last that long, but, Mars is dusty, solar panels.
Yeah. That picture was so dirty.
Yeah.
So dirty.
That's like when you find a sock that's been under your bed for 15 years.
Yeah, gross.
I think my favorite piece of news was the detection of a meteorite impact.
Right. It was the seismic measurements that InSight was taking were not just from quakes. There were meteorite impacts. There were shaking from the wind and the dust devils that occurred nearby. And I think the meteorite impact that it measured loosed a whole chunk of material from the surface, and InSight was able to measure that.
All from one seismometer.
Yeah, one single seismometer.
That's basically magic.
And it's the first seismometer we've landed. No, it's the second seismometer we've landed on another planet. There was a very short-lived one that landed on Venus, and of course the one on the moon. But for such a long duration.
I didn't know there was a seismometer sent to Venus. Was that one of the Venera probes?
One of the Venera probes had a seismometer. It did not last very long, and it did not detect any Venus quakes.
Yeah, and what else could it hear but just the probe screaming anyway?
But technically, it was there. So you can't say that InSight was the first seismometer on another planet, but it was the first functional one that detected quakes on another planet.
Yeah, we just detected 90 minutes of robotic screaming.
Yeah, pretty much.
Yeah.
It could have gotten lucky and they landed on a world that happens to have an earthquake within the time frame of every lander's landing, which would be horrifying.
We put an upper limit on.
Yeah, so
there we go.
Yeah, that's funny. All right, Pamela, you want to just talk about Doom today?
So every AAS meeting, it seems that there are certain themes that come up recurrently. And I have to admit, this AAS does not have the another dwarf galaxy was discovered piece. It did have that's true. It did have we figured out how this part of the sun is heated up press release that there always is. But what really got me was there was two. You laugh because it's true.
I know it's true. Yeah, we figured out the sun. Did you say that before?
Did we know?
Did you hear that? Like, we finally know why the sun's corona is so hot. Like, how many times
Until
did we
the
get
next
press release?
AAS.
You really
Yeah.
don't.
Yeah. So this time, it wasn't so much that there was an ongoing theme as two different press officers both decided doom was the word to use. So the first story of doom is the galaxy UGC 4211. This is an artist's rendition. That's not how it actually looks through a telescope. So the galaxy, it's not that far away in the grand scheme of things. It's 450-ish million light years away. And that puts it at a distance where figuring out what's going on in its core is difficult, but not impossible. And where something is difficult but not impossible, astronomers will write telescope proposals. And in this case, it wasn't just one, it was many. And the group of researchers behind this particular paper, working out of the Flatiron Institute in New York City, they used everything from the VLT in Chile to the Hubble Space Telescope and other telescopes in between, and did spectroscopy of the core of this galaxy. And it was from this ability to measure the rate at which things were going in the core of the galaxy that they were able to untangle things just enough that, as near as they can tell, there are two supermassive black holes, one 200 million solar masses and one 125 million solar masses. And they're just 750 light years apart, which is like closer to us than Betelgeuse is by about a factor of 10. So these two black holes that are millions and millions of solar masses in size are 750 light years apart, and it's estimated they don't have this long to go before they finally merge. Exactly how long this long is, working on it. Stand by, please.
I saw like 100
But
million
are we talking
years.
like thousands of years or millions of
We're
years?
talking
No, I saw like
millions of
100 million
years.
years.
Yeah.
Yeah.
Yes. We're not going to be around to see it, but it is order of magnitude, hundreds of millions of years. But the thing was, this is the first system where they've leveraged this kind of technology, this scope of scopes, to look at the system, and bang, they found what appears to be a binary in a young merging system. And this raises the potential to find more and more of these as our technology improves and as more telescope review boards are forced to admit, yes, this is something the technology is capable of finding. So I fully expect this to be one of many that we're going to identify in rapid order. Now, unfortunately, the very first planet that Kepler was able to rather rapidly identify, which was thrown out initially. So it ended up with a very large Kepler identification. This is Kepler 1658b. It is orbiting a hot star. It's orbiting close to the hot star, and it is losing mass and migrating inwards as it goes, and it probably only has about 2.4 million years left before it is consumed.
That's quick.
Yeah. So, doom. It is all doom.
Boom.
Right. Awesome. Very cool. But not doom, Morgan. Those Russian cosmonauts are going to be able to make it home, right?
They are, yes, just not in the spacecraft they came in. So Pamela gave us an update last week about the ongoing sort of mini crisis of the damaged Soyuz capsule. And we now know that a tiny piece of debris, whether natural or artificial, struck the coolant line, punctured a hole, and drained out the coolant. And NASA and Roscosmos, the Russian space agency, have been noodling together for, and that's the only term you can use when you think about them, have been thinking about how to solve this problem for the last couple of weeks. And just today, I think, they announced what the answer is going to be. And they're going to move forward with speeding up the launch of the next Soyuz capsule and launching it sometime in February. And then they'll try to autonomously return the existing spacecraft to Earth. But because the whole concern is the flight computers might shut down because of heat, we don't really know if that will happen and make it all the way to Earth where we think it will. And they have some contingency plans that they've developed for the period between now and the time in February when this will happen. But the big real outcome here is those astronauts who were supposed to be coming home in March are now going to have to stay probably into September. And so it's like, sure, you're on the edge of death in the space station, but you get a bonus 5 months in space. And that all comes down to the fact that they're accelerating the Soyuz capsule that was already intended to launch astronauts for this March mission. And so by bringing them early, they're going to basically use up that spacecraft as a means for launching the next crew, and they'll have to begin the regular cadence of preparing a new capsule for the Soyuz MS-24 crew. And that's not going to put them until the early fall to be ready for that. And so it's a surprise 5-month extension in space for those 3 astronauts. But it seems like things are pretty well under control right now. And like we said last week, there hasn't been an issue in 23 years of being on the space station that has created a need for something like this. And so all we've got to do is skate through the next 6 weeks, and this random chance accident will basically be in the rearview mirror.
Yeah. So if something happens in 6 weeks, then they're cramming into the Dragon, and hopefully they can make it back down. I'm sure someone's done the math on this. Kimberly,
Hi.
2 stars, 2 Earths for Tess.
That's right. I was actually just thinking back, since I brought up that first episode I was in. I remember the first story I did was about an Earth-sized planet around an M-dwarf star, and I think it's rather fitting that my last Space Hangout story is also about a rocky Earth-sized planet around an M-dwarf star. It's very me. But yeah, so another one of my favorite satellites, because I have plenty of favorite satellites, is the Transiting Exoplanet Survey Satellite, which is basically like Kepler 2.0 or Kepler Jr., the second coming of Kepler, which is my all-time favorite mission. But it's been, cruising around, observing both the northern and the southern sky, doing full all-sky surveys for transiting exoplanets for the past 4, going on 5 years now. And it has discovered many thousands of candidates at a much higher rate than Kepler did, because its observing cadence, 1, is faster, and 2, it is observing the entire sky instead of just a tiny little patch. But yet for all of these transiting exoplanet candidates, this is the first time that Tess has discovered 2 rocky Earth-sized planets, and also in a system that has 2 habitable zone planets. They're not the same planets. One of my... The letters don't quite match up. But there are 2 habitable zone planets and 2 rocky planets in this system. It's TOI 700, and it has 4 planets in there. It's the first time we've discovered that with Tess. And granted, all these planets are like way closer to their star, because it's a cool M-dwarf star. It's a familiar story with M-dwarf stars. The planets are so close in, they're probably tidally locked. The habitable zone is only, a 40-day orbit. All the familiar phrases that we hear with M-dwarf stars. But it's one of those systems that helps us really understand sort of the possible architectures of a wide variety of solar systems and the type of solar systems that probably are the most common that exist. Because don't forget, M dwarfs, most common stars in the galaxy. And if something like this has, 4 tiny-ish planets, habitable zone planets, they're probably incredibly common, and we just gotta, look for them.
How has TESS sort of compared after now multiple years compared to the plans and the expectations for what it was going to find?
It entirely exceeded all expectations because originally TESS's mission was slated for 2 years. It was going to spend a year looking at the southern sky, which it did, in sort of 27-day swaths of the sky. It flipped around and it spent a year doing the same thing for the northern sky. And then its orbit, which is actually pretty unique as far as satellite orbits go, they didn't really know how it would evolve over 2 years, or whether they would be able to have the same kind of fine precision over the spacecraft after those 2-year times. But 2 years passed, everything was stable, and they were able to swap back over and look at the southern sky again. And that's how that they discovered, and for this particular system, that's how they discovered additional planets that they weren't able to see before. Because when you only look at one star for 27 days, you're going to be catching all of the planets that are on really short orbits that orbit their stars, in a handful of days. And so you catch a couple transits and you say, okay, that's a planet. But you're going to miss things that are, 15 days, 20 days, 30 days, let alone something that orbits, in a standard Earth year. But because TESS exceeded, mission expectations, was able to go back and do another all-sky survey of the southern hemisphere, it was able to catch additional planets. And in particular, not just, longer period planets, but planets that were maybe shorter period, like this new one, but were actually Earth-sized or smaller, that have a subtler signal or a noisier signal that it wasn't able to catch on its first pass.
There's a plan for, I think it's a Chinese exoplanet finding telescope. They think they can locate. No, that's right. It's in the NIAC Awards. That's it. There's a new proposal for a telescope that came out of NIAC, the NASA Innovative Advanced Concepts Award, and they're suggesting you could find every single Earth-sized world orbiting around a sun-like star within 10 parsecs.
That sounds awesome.
Yeah. That it would be very specialized.
But I want it to be true very much.
Yeah,
so.
It would be very specialized. So it would have one job, which is to find Earth and find them very close.
Well, and that's sort of what TESS was supposed to be. It's just pushing out farther from what TESS, I think, can see. And it was finding all those bright small planets around nearby stars for James Webb.
But only when they line up perfectly, which is...
Oh, you mean like every?
Yeah, because the problem with the transit, especially with finding another Earth, is the chances of getting an Earth, something that is one astronomical unit away from its star, to pass directly in front of the star from our perspective is very low. So
something like 1% of all Earth-sized planets around those kinds of stars are in the right orientation for a transit. It's like 1% of them.
Yeah, and so when you think about whatever is the number of planets that have been found so far, you actually want to multiply it by 100.
Seems like something that some enterprising grad student is going to pull out of the Gaia data in 10 years with some machine learning algorithm.
Yeah, we detected some kind of proper motion.
Yeah, it's all there in
some
micro arc proper motion.
Yeah.
If you're that grad student and you're listening to this show, please do that.
Yeah.
I want that.
Yeah. I'm sure they're on it. So as we sort of near the end of the show, I want to give my co-hosts a chance to talk about what they're working on and where people can find out more. So Kimberly, what are you working on right now? What projects have you got on the go?
Oh gosh, I'm just back at work after a long extended leave. So I don't have any projects going right now, but things I'm looking forward to this year include Lots of writing for eos.org, which is where I've been for the past few years, and I don't see that changing. We're doing a couple special issues that I'm really excited for about climate history, and one all about ocean worlds, including most of the ones in our solar system, which I'm going to have my sticky fingers all up in there, which is exciting. Yeah, you can check me out. I'm always on eos.org and not so much on Twitter anymore,
Yeah.
but you know
What?
how Twitter
What?
goes.
What?
If you're still on Twitter, I guess I still have an account.
Yeah. Morgan.
Oh, you can find me on eos.org as well, not nearly as often as Kimberly, but once in a while. You can come by your Science Center here in beautiful Nashville and check out. We are renovating from top to bottom, bit by bit. The science is everywhere. So come say hello. And you can always keep track of me at morganrenberg.com.
Wonderful. And Pamela, you've got a lot of irons in the fire right now.
I do, and I'm actually going to show off for a moment. I have art this weekend in my very first art show. So I'm going to be in Boston and at the Eurasia Convention, which requires all the vaccines and all the masks. So I actually feel kind of safe about going. And if you are there, go check out my art in the art show. I'm kind of excited about that. And other than that, we are getting ready to launch Escape Velocity Space News over on CosmoQuest. And we're moving forward with everything else. Astronomy Cast. I forgot today was Wednesday, so we're actually going to be recording that next Tuesday.
We were supposed to record a show today.
I was
waiting.
I was quite sure today was Tuesday. I was very sure today was Tuesday. So yeah,
Well,
apparently
I'm glad we cleared that up for you by now, because we also do the Weekly Space Hangout on Wednesday. So
it's true.
Yeah, awesome. And of course, I'm Universe Today and all the things. And I think so people who've reached the end of this show and they want to continue the journey, what are the places that they should subscribe to so that they continue to see the work that we're doing, that the sort of the community is doing? So obviously, if you haven't already, you should subscribe to Astronomy Cast, and that's going to continue on, as well as my podcast at Universe Today and YouTube channel.
Both Universe Today and CosmoQuest have newsletters that have very different content, so you will be getting all sides of the space news community if you subscribe to both of them. And I know I'm covering the stuff that Kimberly and Morgan are writing over at EOS on a regular basis.
Yeah, it's one of my favorite reads, actually.
Yeah, it really is.
It's such good
Almost
reporting.
every Weekly Space Hangout person is writing on Universe Today, it feels like.
Yeah,
and if not now,
or
in
EOS.
the future, or in the past.
Or SETI.
They're everywhere.
Yeah.
So that's definitely where to go.
Yeah.
Wonderful. And the WSH crew continues.
Yeah. All right. So for all of us today, as well as all of the co-hosts who aren't here tonight, as well as all of the co-hosts who have joined us in the past, all the way through history, think about names like Phil Plait, Emily Lakdawala. Just so many cool people have been part of this project over the more than a decade, and it's time to shut it down. So thank you everyone for watching us today. Thank you to all the moderators who were in the chat today, and a huge special thank you to Nancy Graziano. I hope we did you proud. Thank you for everything, and we will see you offline, Nancy. Thanks, everyone.
Bye-bye.